Hello, hello, hello. Am I audible?
Yes.
Okay, great. Okay, so what we have done in the last class that we discussed questions based on the concentration terms. And we have already discussed the last concentration term, which is your mole fraction. Have you remembered everything? The questions that I have given you in the homework, have you solved that, the questions?
Yeah, the homework, and you sent some
What?
assignments in the. Yeah, I did it. I submitted it.
Okay, you have submitted. Okay, so I'll check that. Fine. So
Okay.
now let's start. So there's the two parts which are remaining, like, and you need to find the molality and the mole
Or
fraction.
I'll take
Yes. So have you solved this?
more fraction.
Have you solved it?
Yes. Yeah, I did,
Okay.
but I don't know if it's the right answer.
But what?
I don't know if it's the right answer. I got.
Okay. Okay. Okay.
Okay.
Got it. So I'm going to solve this one for you. So let's see here. So
Okay.
this is the thing that I need to find molality. So for molality, what is the formula
Molarity.
of the molality? The formula of the molality is your
Number of moles by
number of moles divided by
solute.
weight of
Uh, Weight of
solvent
solvent.
in
Yes.
kg, right? So first of
Yes.
all, you need to find
Yes.
the moles, and then so what is given in the question? The things which are given in the question is
20.
20 gram mass by mass. That means that 20 gram of solute is there, and which solute? This one, and the molar weight of this is 166 grams. So if I divide this
166. Yeah.
to this one, so what I'll get the now what is the weight of my solvent? So for the weight of my solvent, what I need to do? I just need to
80.
subtract the 20 from 100. So I'll get the weight of my
100.
solvent,
Yeah.
which is 80 grams. Am I correct?
Yes.
So now 80 divided by 1000. This is for
1000.
in order to convert this into the kg. Fine.
Yeah.
Okay. So now on solving, what I'll get, I'll solve this. Just 1 minute. So 20 divided by 166, I'll get 0.12, 0.12. And if I divide this, so what I'll get 0.08. So if I divide this
So
one
8.
to 0.08, I'll get
1.5.
I'll get 1.5 as my answer. Correct? So this is my
Yeah.
answer, and this is there in the molal. Now, now let's move on to the
Yes.
next part, which is the mole fraction. So in order to find the mole fraction, we have already find the moles of my what? Of my solute, which is there, and
Salute.
I need to find here for the mole fraction of my solute. For the mole fraction of my solute, I need to find the moles of my solute divided by moles of my solvent plus moles of my solute. So how to find the moles of the solvent? So just divide the 80 to the molar mass. And what is the weight of my solvent? So this is the Ki
Yes.
aqueous solution. Aqueous solution means that this Ki is dissolved in a water. So what is the weight of
What?
my water?
18.
It is
18.
18. Fine. So if I divide the
18.
80 to
Yes.
18, I'll get what? I'll get 4.44. 4.44
Yes.
as my moles. So
44.
0.12 divided by 0.12 plus 4.44. So if I add this one to like add if I add this one, if I add this one with 0.12, I'll get 4.4
5 7.
56, correct? And this one is divided from.
Yeah.
So what is the final answer? What is your final
0.
answer? 0
0
point
point 026.
divided by
026.
4.56. You will get 0.02. 0.026 moles. Correct?
Yes.
So this is the answer for the mole fraction, and this is the answer for the molar. So have you got the answers? Hmm?
Yes.
Is there any doubt?
Yeah, I got this. No,
Huh?
I got the same answer.
Is
I
there any
got the
doubt?
same answer as well. No,
Okay, fine. Got good. That means you are, revising if you are getting the correct answer. Good. Now let's start to the next topic. The next topic is my solubility. Solubility. What do you understand by this term solubility? Like this is a general term, solubility, soluble in something. So can you tell me what is the
mm,
definition or something that you know about solubility?
it's the maximum amount of solute that can be dissolved in the
The
solution
maximum amount
at a
of
particular solute that can be dissolved in a solution
correct,
or
correct, correct.
solvent
Correct, correct.
in a
So
particular
basically, the
temperature.
definition is you have quoted the correct definition. So the maximum amount of solute that can be dissolved that can be dissolved in a that can be dissolved in a solvent.
Or
Correct,
solvent.
which is known as your solubility.
Yeah,
Fine. So now the question is ki, what are the factors that can affect the solubility? What are the factors? Like for
temperature.
example, I'm having factor like I'm having some factors. For example, I'm writing here factors affecting solubility. Okay, solubility. So factors affecting solubility, I am going to tell you. So the first one is my endothermic, like not endothermic, I can say temperature basically. Temperature. The first one would be my temperature. So can you tell me how the temperature is related to the solubility? Like if I'm having a solution of sugar solution. For example, for example, I'm having sugar solution. I'm having a sample of sugar solution. So this sugar solution is a solution having two components. One is my water and the other one is my sugar. Correct? Sample of
yeah.
sugar solution. Now tell me, if I increase the temperature, what will happens to the solubility? What will happens to the solubility if I increase the temperature?
It will increase.
Huh?
Solubility will increase.
Solubility decrease. Like
Increase.
this is the beaker. Okay. And I have put this beaker on a gas stove. Okay. So this is the gas stove. You know, or I can say I have put it on a burner. That would be a better word. Burner. So if you see here, this is my sugar solution. Sugar solution. And in that sugar solution, I have increases the temperature by putting it on a burner. What will happen? My sugar, which is there in the solution, is gonna dissolve more. Is gonna dissolve more.
Yes.
Are you getting my point?
Yeah.
If you state the solution, like for example, when you used to make a sharbat, do you know the sharbat thing?
Yeah.
So what will happen? There is a water, and in that water, you just stir the solution, sugar solution. Why you stir the solution? So that the sugar gonna dissolve in that solution, and your what you can say your sharbat will gonna form, है ना? After stirring that. So
Yeah.
what you are
Yeah.
doing then? What you are doing? You are providing the energy from the external environment. You are applying the energy. You are doing the stirring thing.
Yeah.
So why you are doing the stirring thing? Because you need to increase the solubility. Fine.
Yeah.
You need to increase the solubility, so that you are doing that. So if I increase the temperature, my solubility increases. Solubility increases. Okay, solubility increase. Now, what I need to tell you is that if my solubility increases, then now I am having another example. Like if I'm having a cold drink, okay, and in that cold drink, I'm having a solution of my gas, which is my CO2, and my drink part. That I can say that this is the solvent. Sweet drink that is there in the solution.
Mm.
है ना?
Yeah.
So if I now if I increase the temperature, what will happen? Is the solubility of gas increases or decreases? The solubility of gas increases or decreases? Can you tell me?
Decreases.
Huh?
Decreases.
Decrease, correct. Why? Because if you see, I'm having a cold drink bottle, and if I open the cap, there is a sound of whistle sound which comes up. Why? Because there is a gas which is
Mm.
escaped out. And if the gas is escaped out into the environment, this whistle sound creates, and this tells me that the solubility is basically decreases, है ना? If I open that bottle.
Yeah.
But I am just trying to tell you this solubility thing in terms of the temperature. So if I again put the cold drink on a burner, my gas will all the gases which is there will gonna escaped out, so my solubility decreases. So now, if you have any doubt, you can ask me. Just give me 1 second. I'm having an important call, so just give me 1 second, okay? Now, till now, you
Okay.
can write all these things that I'm writing. Okay.
Okay.
आपने जिस व्यक्ति को कॉल किया है वो अभी
Got it? Everything that I have explained you.
Yes.
Okay.
Understood.
So now there is a thing. There is two type. There is two type of process. Just 1 minute. Just 1 minute. Sorry. Okay. So see. Now, I'm going to tell you the processes. There is a thing which is known as process, chemical process. The chemical processes are of two types. The one is my endothermic process, and the other one will be my exothermic process. Fine. Endothermic process, exothermic process. Fine.
Yes.
Now, see, what do you mean by endothermic process? The endothermic process is a process in which I apply the energy, I give the energy, I give energy from outside environment. Okay. Externally, or I can say externally energy is providing. That means that if I give energy from if I give energy externally, like for example, I have put it here the burner, the externally I have put it the burner, what will happen? My solubility increases. So if the process, if any chemical process is my exothermic process, is my endothermic process, it is a process in which the externally energy is required in order to in order to proceed the reaction, in order to complete any chemical process, what you need to do, you need to apply the energy externally. So this is known as your endothermic process. So now if you see here, if I need to dissolve the sugar into a solution, initially the solution, the sugar is gonna dissolved by its own. And if you stir the solution, my sugar is going to be dissolved. But after some time, you'll see that if I add more and more and more sugar, the sugar is not going to be dissolved in that solution. There is some crystals you can observe in the bottom part of the
Yeah.
beaker. If you take a glass of a if you take a glass bowl, and if you add the water in a water if you add the sugar in a water and you stir that, initially the sugar is going to be dissolved in that, so in that water. But what will happen if I just increasing my solute quantity, increasing my sugar, adding more and more and more, there is a point at which the sugar is not going to be dissolved in that solution. There is some crystals you can observe at the bottom of the bowl. Fine. Now, when you
Yeah.
increase the temperature, when you put this bowl in an oven, what will happen? The sugar is now gonna dissolve. The sugar, the crystals that you are seeing in the bottom part is also going to be dissolved in that solution. And how this will gonna happen? By just increasing the temperature. So you are going to apply the energy externally. You apply the energy externally so that this chemical process, this process will take place. So such type of process in which the energy is required from the external environment is my endothermic process. And the processes which releases the energy, it is a process in which the energy is going to be released out. The energy is released out. It is a process in which the energy is going to be released out at the end of my chemical reaction. So such type of processes are known as exothermic process. So if I take the cold drink. So in that solution I'm having the CO2 gas and my the drink which is the sweet drink which is there in that bottle. So if I increase the temperature, my gas will escape out. That means that my reaction will goes to the backward side. But if I put it, if I like for example, if I explain you, like if I tell you if I'm having this nascent oxygen, and here this is the nascent oxygen, and if I put these two nascent oxygen close to each other, what will happen? These gases will automatically, these two elements automatically combines to form oxygen gas. And if this gas, if this oxygen gas,
Yeah.
formed, then there is an energy which is released out. Why this energy is released out? Because if you see that if any chemical reaction will takes place by its own, that means it is a natural process. Then what will happen? These two elements having the energy higher, and in order to achieve the stability, what will happen? The chemical process will takes place and the energy will goes down. How this energy will goes down? In order to achieve the stability, if you need to achieve the stability, the energy should be released out. So in order to release the energy, this is the process which is known as your exothermic process. Okay, so this is the process which is known as the exothermic process, in which the energy is going to be released out. And if you see here, if I increase the temperature of any exothermic process, my solubility will going to be decreased. My solubility is always and always going to be decreased if any
Yes.
process will take place by its own. Okay, so these two types of processes are there, and there is a relation between the temperature and my solubility. So, is there a directly proportional relation or an inversely proportional relation? It is just based on the process, which process we are talking about. If you are talking about the endothermic process, that means the solubility is basically directly proportional to the temperature. But
Directly
if you are
proportional.
talking about the exothermic process, that means the solubility is inversely proportional to the temperature. Got it?
Mhm.
Now, the
Yes.
next factor is my pressure. Next is my pressure. Now, again, the same thing. There are three states of matter. The first state of matter is my liquid, solid, and this is the gas. So, if you see, if I compress, if I if I try to compress, try to compress my liquid or solid, these two are not going to be compressed out. These are incompressible. So we are not going to discuss about the factors in, we are not going to discuss about the factor of pressure in liquids or solids according to the, in order to make a relation between the solubility and the pressure in such type of matter, states of matters. But if we talk about the gases, then what will happen? If I compress the gas, what will happen? My solubility. What do you think? What will happen with the solubility if I compress the gas?
It will increase.
Hmm?
Increase.
Increases. True. And vice versa. है ना? Vice versa.
Yeah.
So these are the two factors, and the third one is my your nature of my solute and solvent. What do you mean by the nature of the solute and solvent? Like dissolves like. This is the statement. This means that if I'm having a solute and the solvent as my solute and solvent, both either I can say it is organic, or I can say polar, not organic, polar, basically polar and non-polar. If I am having both the solute and the solvent as my polar compounds, then then the solubility increases. Solubility increases. And same with the non-polar thing. If both of them are non-polar, the solubility increases. But if what happens if both of them having either one is polar or non-polar, like for example solute is polar and solute is non-polar, or I can say ki solute is non-polar, solvent is polar, then the solubility decreases. Simple. And what do you mean by polar? Polar means ki compound having dipole moment. Dipole moment. Do you know what is dipole?
No.
Elisha, do you know about what is
No,
dipole
sir.
moment?
No.
Huh?
No, I remember. No.
Okay. So do you understand what is polar or non-polar?
No.
No? Okay, fine. So I'm going to tell you what is polar and non-polar. If anything that I used, any term that I used, and if you do not know about that, you can ask me. Okay. So what do you first?
Okay.
You need to understand what is polar and what is dipole moment. Then I'll tell you what is polar non-polar. So for example, I am having a charge plus q and minus q, and this thing will comes under your physics wala part, basically. So if I'm having plus q and minus q as my charge, which is separated by a distance r, fine. Plus q minus q, I am having plus q minus q as a charge with a difference of r. You know, there is a distance which is there, which is r. Now, if you see this q charge is equal and opposite. These charges are equal and opposite. Equal means that the magnitude of the charges are equal and having a opposite charge. For example, one will be a positive charge and the other one will be my negative charge, but the magnitude of the charges will be the same. Like for example, 10 coulomb plus 10 coulomb and minus 10 coulomb, or for example, minus 5 coulomb or plus 5 coulomb. So this apparatus is basically known as my dipole. This apparatus is known as my dipole. Now, what is dipole moment? What is dipole moment? Basically, if you dissect this term, di means two. Di means
Hmm.
two, and pole
Two.
you already know. The extreme ends are basically the poles. So if you see the extreme ends, you can observe that there is two poles are there. First one is my plus q and the other one will be my minus q. So this is basically my dipole. And what is dipole moment? So dipole moment is nothing but there is a movement of, you can say that ki there is a movement of electrons. Basically this is my electric field. I'm not using the physics wala term. Basically there is if I am having a dipole, that means there is a thing which is known as dipole moment, which is related to it. And what is dipole moment? You can ask your to your physics teacher. They can tell you what is dipole moment. But till now, for time being, basically if I'm having an apparatus of dipole, then there is a movement which is related to this dipole, which is known as my dipole moment. And which type of movement I'm talking about? I'm talking about the movement of my electrons, basically. Fine. So if you see here, so the dipole moment will be from plus to minus. Okay. So this is my dipole moment. I'm not this thing is my dipole moment, first thing. And if any compound, for example, if I take H2O, now I'm going to come into the chemistry wala part. So if you see here H2O, oxygen is my electronegative element and hydrogen is my electropositive element. And you know what is electropositive, electronegative? I have explained you what is electropositive, electronegative in the earlier class.
Yeah.
Have I discussed electronegative,
Yes,
electropositive to
sir.
you?
Yeah.
Huh?
Yes.
So if you
Yes.
see that oxygen having a high electronegativity, that means that oxygen having the tendency to attract the electrons more in comparison to the hydrogen. Basically, hydrogen having the electronegativity as zero because hydrogen is my reference point. So that means that oxygen having the higher electronegativity. So if the oxygen having the higher electronegativity, that means it is having a tendency to attract the shared pair of electron. So the dipole moment will be like this. So if you see that plus to minus is my dipole moment here. This one is my partial positive, this one is my partial negative. So the dipole moment is like this. Dipole moment is like this. So these compounds having the dipole moments, I can say that these compounds having the dipole moments are my polar compounds. What are the polar compounds having the
Oh,
dipole moment? The compounds which are having the dipole moments are my polar compounds. And what is non-polar compounds? The compounds which do not having the what? Which I can say that do not have any dipole moment. Fine.
dipole. Yeah.
Yeah.
Yes.
So this is my you know basically polar and non-polar, and that will comes up under the nature of solute and solvent. If both my solute and solvent are polar, I can, or polar or non-polar, I can say that the solubility is going to be increased if I add both of them. And if they are having the different nature, like one is my polar and the other one is my non-polar, then I can say that the solubility is not going to be increased, it is basically going to be decreased. Fine. Now I am going to move to the
Yes.
next section, that is my Henry's law. These are the factors that are responsible for the solubility. I have discussed everything about the solubility. Now, if the examiner asks you about the solubility, first you need to write the definition of the solubility and the factors that can affect the solubility. I have already explained you everything. Now I'm going to discuss the your next section, which is my Henry's law. Henry's law. So now, basically, what is this Henry's law? I'm going to first of all, I'm going to write the definition, then I'll explain you. So according to the Henry's law, according to you can write with me, and then I'll explain you. According to the Henry's law, the partial pressure, the partial pressure of the gas, the partial pressure of the gas is directly proportional directly proportional to the mole fraction of the gas. Directly proportional to the mole fraction of the gas. So now basically what I have written here. according to the Henry's law, what is this Henry's law? Henry's is basically a scientist that given this law. So according to the Henry's law, the partial pressure. What is partial pressure? The pressure which is exerted by the gases which is there. For example, I am having a beaker like this. I'm having beaker like this. And this is a closed container, not a beaker, basically closed container. Fine. Now, how I have closed here, I have, taken a pistol. This is my pistol, and through this pistol, I have closed this container. So if you see, this is my solution. This is my solution. This is my solution. And if you see that this solution is having a solvent and solute. The interesting thing is this solute is in the form of gas. This solute is in a form of gas. So if you see that if it is in a form of gas, that means there are some particles of gas which is there like this. And if you see that this is a solution, that means that in that solution it is a mixture. This solution is basically a mixture of solvent and solute. That means that some amount of gas is dissolved in that solution and some amount of particle which is there on the upper surface of that solution. So basically, if I apply the pressure from the upper part of that, so the particles which is there in the environment is going to be dissolved in that solution more. For example, if you see a bottle of a cold drink bottle, and there's a cold drink bottle, for example, like this. This is a bottle. If you see, like this is a bottle, and is it visible? I think, huh? So this is visible. This is a bottle. So if I open this bottle, the gas which is there, if you consider this is a cold drink bottle, the gas which is there inside that is going to be escaped out if I open this, I can say, what the cap of a bottle. If I open that, the gas will going to be escaped out. But if I do this, like if I close this cap and close the container, the gas which is there is pressurized. And if the gas is going to be pressurized, that means some amount of particle is going to be dissolved in that solution. So if some amount of gas which is dissolved in the solution, which makes this one is as a solution, the particles of the solute is going to be dissolved in a solvent, and this dissolution makes this complete apparatus as a solution. Now what I going to explain you is that if I apply more pressure on it, then the partial pressure of the gas which is going to be exerted out on the surface of the solvent solution. This is the surface of the solution. The particles of the gas going to be pressurized on the surface of the solution. Then the partial pressure, the amount of solute which of gas which is going to be dissolved in that solution is basically directly proportional to the mole fraction. What I am trying to say is that these are the particles of gas. See, particles of gas. If I pressurized these particles, these particles going to be dissolved in that solution. Particles of gas dissolved in the solution is basically depends on the mole fraction. I can say mole fraction of the gas. Understood? So basically it depends on the mole fraction of the gas. So the partial pressure is directly proportional to the mole fraction of the gas which is there in this solution. Understood or not?
Yes.
So can you tell me what is Henry's law?
Henry's law, the partial pressure is directly proportional to the mole fraction of the gas.
So the mole fraction of the gas which is there at the upper side of the solution. Fine. So this is the thing. Now if I remove this proportionality sign, I'll end up getting a constant. I'll end up getting a constant which is k, which is my kh. This is my
Okay.
constant. And which constant it is? It is a Henry's constant. Henry's constant. Fine. This is a Henry's constant.
Yeah.
Understood? So this is my
Yes.
Henry's law. Now I am going to give you a graph. This is my Pg, partial pressure of gas, and this is my mole fraction of gas. Can you tell me what is the how my graph is going to be look like? Can you tell me after seeing this? This is the equation. This is the equation. And I think you're a PCMB student, or you're a PCM student, or PCB student?
PCM. Yeah.
Huh? PCM, na? You have maths.
PCM. Yeah.
So can you tell me
Yes.
after seeing this equation, can you tell me how this graph gonna look like? And this is basically associated with this like this. Y equals to mx. So can you tell me what is the graph? How this graph going to be look like?
Just a straight line
Huh?
incline.
Straight line?
Like a straight line incline.
Correct, correct. 100% correct.
Like
Straight line.
upwards
Huh,
incline.
correct. A straight line. So this is how my graph will going to be look like. And the slope is basically my kh. है ना? Correct.
Yeah.
Now there is a thing which is my applications, basically applications on Henry's law. Before discussing the applications, I'm going to give you some questions. Till that you write the question, solve the question, then I'll tell you this. So the question is, write the question. The question is, if nitrogen gas, if nitrogen gas is, it's a very good question, है ना? It might be come in your exam. Through water, 293 Kelvin at this temperature, then how many how many milli how many millimoles of N2, how many millimoles of N2 gas would, how many millimoles of N2 gas would dissolve in 1 liter of gas? 1 liter of gas, water. Assume, write the question with me, okay? Assume that
Yeah.
N2 gas exerts a partial pressure of 0.987 bar, given that Henry's law constant, Henry's law constant kh is basically 76.28 kilo bar. So this is the question. Now solve this one. Read each and every line very carefully. If anything that you are not able to connect with, you can ask me. Any question? So I'm going to explain you the question first, then you can solve this. So I'm having N2 gas, fine. And N2 gas is bubbled through the water. Basically, what is this? This is basically a solution of N2 gas and water. This makes a solution, fine. At 293 Kelvin, that means that it is at room temperature. Room temperature, which is 25 degrees Celsius. Fine. Now see, then how many millimoles of N2 gas would dissolve in 1 liter? So the question is how many millimoles? That means how many N2 moles. Basically, the question is asking you to tell me the moles of N2 in terms of your 10 to the power minus 3. Okay. So you need to tell me the number of moles of N2 gas in 1 liter of gas. Okay. So assume that means this question is asking you about the molarity basically. Molarity is asked this in this question. Molarity is asked you because what is written here? N2 gas would dissolve in 1 liter of gas. 1 liter of gas water. That means there's a water. In that water, my N2 gas is dissolved, and the water is 1 liter. So the moles which is there in 1 liter is basically the molarity. This is the definition of the molarity. The molarity is going to be asked to you, and that N2 gas exerts a partial pressure of barrier. So that means pressure is given to you, and how much pressure is given to you? 0.987 bar. Okay. And what is given to you now? Henry's constant, which is 7628 kilobar. That means 10 to the power 3 bar. So now, all the things which is there in the question, the given data, I have explained you. Now just apply the formula. Apply formula. Which formula? Just your Henry's law, which is Pg equals to Kh into your mole fraction of gas. Just apply this formula, tell me the answer. Basically, millimoles is asked to you. So basically, if you find the moles, you can easily write the moles is basically equals to the molarity. That's it. So you need to find the moles from here. So if you see, I'm also extend this one more. Pg is equals to Kh into my number of moles of N2 divided by number of moles of N2 plus number of moles of H2O. So see, you need to just find this one, this thing that you need to find. That's it. So now the question is very much simplified. The question is solved. Just you need to put the values and get the answer. That's it. Okay. Have you written the question?
Yeah, I wrote the question.
Huh?
Yeah, I wrote.
Okay. Fine. You just solve the question. I'll explain you that I'm writing here. Okay. Solve it.
Could you go back? I didn't
Okay.
write
Okay.
the.
You can easily write these things by your own self. This thing is basically the question that is there. And this is the formula that I have applied and that I have explained you in the last page.
Hmm.
So everything is, known to you. Just you need to use your brain to solve the questions just by putting the values and all. Fine. Can I change the page? Because I need to write something.
Yeah,
Okay.
yeah.
Done, Elisha?
No, sir.
You are facing some difficulty, you can ask me if at any stage, like just you need to find this one.
How do
I'm going to give you a hint.
how do you find?
I'm going to give you a hint, a very good hint. The hint is that after that you should need to solve this after I'm giving you the hint. So if you see here, this one, this moles is going to be in millimoles. This is written here that my N2 gas having the moles are in terms of millimoles. That means 10 to the power of minus 3 moles. Fine. It is in millimoles. And if you see this H2O gas, then you can see that this will be in, you know, in how, in which terms. This one will be the weight of my what? The weight of my water. So the weight of my water is the weight of my water is given to you or not?
Yeah.
Hmm?
Wait.
Is it given to you or not?
1 liter.
Huh?
Is it 1 liter?
I'll tell you. The weight of the water is given to you. How? If you see the water gas is in 1 liter. Fine. So if the water gas is in 1 liter, see, if the water gas, okay, is in 1 liter, like volume of gas, volume of water, I'll write volume of water. Okay. So if the volume of water is 1 liter, then what is the weight of my water? How you can find this? Just by applying the formula of density, mass upon volume. Can you tell me what is the density of water? Is it 1 gram per ml? Is it per ml cube?
Yeah.
So if you see, this is my mass. So this one you need to find, and 1 liter is given to you. So if you multiply 1 into 1, you will get 1. What this one will be your 1 kg. This one will be your 1 kg. This one is your weight. If you see, fine or not?
Yeah.
Are you getting my point?
Yes,
So
fine.
if you see that
Yeah.
here, this means ki 1000 grams of water is given to you. From this information, you can find the weight of the water. And if you divide this 1000 to 18, what you will get? You will get something around 55 point something, 55.5, I think. Is it? I'm correct? 1000 divided by 1000 divided by 18, you'll get 55.5. Yes, I'm correct. You can write, you can learn this one key. If you divide 1000 to 18, you will get 55.5 because it's a very famous calculation. So if you see 55.5 is my moles, fine. And if you compare this 55.5 to 10 to the power of
Yeah.
minus 3 mole, there is a huge gap between them. There is a huge gap. If you see, there is a huge gap
Huge
between
gap.
these two moles. This one is in my millimoles, and this one is my in terms of 10, 10 to the power 1. This one is in the terms of 10 to the power 1 mole, and this one is in terms of 10 to the power of minus 3 moles. So there is a gap of how many tenth places? 4 tenth places. And if you see that, if for example you are
Okay.
having this much of money, you are having 10,000 rupees, and if I took 1 rupees from your 10,000, will it affect you much?
No.
है ना? If you are having 10,000 rupees, and if I took 1 rupees from that 1,000, from that 10,000, it's not going to be affect much to you. Fine? Is it? So you can
Yeah.
so what is the purpose of explaining these type of things? The purpose is that you can easily ignore the N2, the number of moles of N2 here, because if you add 10,000 to 1, it is basically approximately equals to the 10,000. If I add anything with 1, like for example, if I add 10,000 to 1, this will is going to be approximately equals to the 10,000. Fine. So I can easily ignore this term,
Okay.
moles of N2. Now you can solve this. Here you are having the moles of N2 at the upper part, and at the lower part you are having the moles of H2O that I have calculated here. Just you need to put the values and get the answer. Now solve by your own self and tell me the
Okay.
answer. It's a very good
Fine.
question. I have
How do you get
already.
the moles of N2?
Huh?
Moles of N2, how do you find the moles of N2?
How I find the moles of?
N2.
This is the question that you need to find. In the question, you need to find the moles of N2. In the question, it is written there millimoles. So what is the
Okay. Okay.
basically meaning of millimoles? The basic
Yes.
meaning of millimoles is the mole is going to be in terms of 10 to the power of minus 3. So that you need to find it. Okay. So it's a very good question because in each and
Okay.
every line, there is something which is hidden. For example, if you see the first line tells you that it is a solution of nitrogen and water. And if you see the second line, it tells you that the N2 gas is in terms of millimoles, and it is having a very important point that if it is there in millimoles, you can easily ignore this one. If you add anything, like if you add 10 to the power of something with the 10 to the power of minus 3, you can easily ignore that because it's a very huge number, and you are adding 1 into a very huge number, है so you can easily ignore this
Mm.
one. And the another line, this tells you that if 1 liter of gas is written, that means that this information is going to help you to find the weight of your water. This is very important point. And now the next line will tells you the your pressure of the gas, and the last line will tells you the Henry's constant. So every line have some meaning, some information which is there. Fine.
Yeah.
So this is a very good level of question, है ना? So you can learn the concepts from this question. And if you're not able to solve this, it's completely fine because at the first attempt, no one can going to be solved this type of questions because many things which is hidden in this question. So it's fine if you're not able to solve that. But after that, if such type of questions will come up to you,
Okay.
so you should need to solve these type of questions. Fine.
Fine.
Okay. Done.
Yes, sir.
Elisha, complete.
Yeah,
Okay, so tell me the
I
answer now.
add enough is correct. 0.66 into 10 raised to minus.
What?
0.66 into 10 raised to minus.
Okay, so 0.666. So your answer is 0.666. Okay, let's find out. Okay, let's see. So the formula that I'll come up to is this one, and number of moles of N2 divided by number of moles of H2O. And if you see 0.987 equals to KH would be my how much? 76.28. 76.28 into 10 to the power of 3 because it is in kilo. And if you see this one N2, and this is my NH2, which is 55.5. This is my number of moles of water. So if I solve everything like this, if I 0.987 multiply 55.5, if I divide this 76.28, and if you see if this 10 to the power 3 goes to the LHS RHS side, this one would be my 10 to the power of minus 3. This one tells me the millimole. Milli. Okay, so I just need to find this and quote the answer. This one. So point 987 multiply to 55.55, we will get 54.82. So if I divide this to 54.82, I'll get 1. I'll get 1. 76. No, just 1 minute. If I divide this, like if I divide this 54.82 to your 76.28, I will get 0.718 moles. So the answer, you're close, you're too close. Your answer is 6.66, but the answer is 0.71. So this is the answer. You're too close. That means you have done some mistake in the calculation part. Fine. So have you understood everything that I have explained you? Everything that if you face any difficulty, you can ask me. At any
So
stage you can.
does the temperature matter?
Okay, see, I'm going to explain you this one more time. See, this formula I need to apply.
Yeah.
Fine. And I'm going to extend this formula like this. Number of moles of N2 divided by number of moles of N2 plus number of moles of H2. Fine. Now the question is, I need to find this one. I need to find this one. Now, here also this one is there. The thing which is there I need to find is also there in the denominator part, and it is going to be added to the H2O. So in question, what is given? According to the question, the given thing is my N number of moles of N2 is in terms of millimoles. This tells me that it's a very small number. It's smaller number in terms of if I compare this to my number of moles of what your water. So I can easily
Water.
ignore this one. I just put this as 0. And how I know this one is a larger number? Just by knowing ki 1 liter of your H2O is there. So if I use the formula of my density, that means mole upon volume, I can easily get I know the density of water is 1. So if I solve this one, I'll get 1000 gram as my mass of my water. So if I calculate the number of moles of hydrogen H2O, I'll get 1000 divided by 18. So the answer would be 55.5. Fine, moles.
Yeah.
Correct. So after comparing this one to this millimole, I can easily say that my number of moles of H2O is more. Fine. Now,
Yeah.
if I see here, this is my partial pressure of gas. So this one would be 0.9 and 0.987. And if I put here 76.28 into 10 to the power of 3 and number of moles of N2 divided by 55.5. Now this one is just the calculation. After solving, you'll get your final answer as 0.71 moles. Fine. Understood?
Yeah.
Now, is there any doubt?
No.
Fine. Okay. Now we are going to move towards the application part of the Henry's law. And what are the applications? In the real life, like I'm going to give you the examples where the Henry law is applicable in the real world. So if you see, there is a condition which is known as bend condition. What is this bend condition? Basically, this condition is related to the divers, scuba divers, scuba divers. So who the scuba divers are? So basically, these are the divers, these are the deep divers that will go deep to the ocean. Basically, they dive deep to the sea or ocean and anything. Ocean. Fine. So they go deep to the ocean, sea, etc., etc., and in a water. So if I see here, if they go deep down to the water, there is a thing which is known as the pressure. You know that if I go deep down into the water, the pressure is automatically increases. Have you know this? How this pressure is increases?
Yeah.
I'm going to quote the chapter which is your fluids. Your in your class 11 there is a chapter which is your fluid mechanics, class 11 physics, and there you have read about the dynamic fluid, static fluid, and etc. and etc. So there there is a thing which is known as your pressure, and the pressure, if you go deep down to the water, how much pressure the water will exert? Rho gh. Do you remember this one? Do you remember this thing? Rho gh. Rho gh is there in your class 11th. Class 11th physics. Have you remember?
No.
Okay, fine. So see if you do not remember this one, it's okay, it's completely fine. See here, this is basically just see, this is a formula. This is basically nothing but a formula. What is it? It is a formula of my pressure. What is it? It is a formula of my pressure if I go deep down into the sea. How? This formula is basically dependent upon the h. H is my height. Like height, no, it is basically the depth, how much you are going into the water. So if you go more deep down into the water, the pressure is going to be automatically increases. Fine. This thing that I need to tell you ki basically my pressure is going to be increased. Basically, my pressure is going to be increased if you go deep down into the water. So if the pressure is increases, that means that the solubility of gases will also gonna increase.
Yes.
Fine or not? Like if the pressure increases, that means the solubility also increases. See here. Like here, the factors. In the factors part, this is my pressure and C gases. So if I compress the gas, that means if I increase the pressure, if pressure is increases, the solubility is automatically increases.
Yes.
Fine. So that means that the scuba divers that go deep down into the ocean, they have a oxygen cylinder with them. They carry the oxygen cylinder with them to breathe, to get the oxygen. And that oxygen cylinder, there is a change in concentration of air. Why? Because if you see air, there is some composition. If you see the air, there is some different composition of gases are there. Like for example, like 71% of nitrogen is there, and 0.03% of CO2 is there, and 28% something around is oxygen is there. So these are some compositions which is there in the air that we breathe in. है ना, at the what, at the
Yes.
at your surface terrestrial level. Fine. So if you go deep down to the water, there is a thing which is known as the oxygen cylinder that the scuba divers that they can carry with, so that they can breathe. But in that oxygen cylinder, the concentration of all these gases are not equal to the air, are not equivalent to the air. Why? Because basically we at the terrestrial point we breathe here, but if you go deep down to the water, there is some change in the external conditions which is there in the terrestrial level. Why? Because at the terrestrial level the pressure is 1 atm, but if you go deep down to the water, the pressure is increases. That means you should have to change the concentration of the gases according to the external condition. Fine. So if you change the concentration of the oxygen cylinder, how are you going to change? Basically, you need to change the percentage of nitrogen gas. Why? Because you need to decrease the percentage of nitrogen gas which is there in the oxygen cylinder. You need to increase the percentage of helium gas. Why we are doing this? Why we are decreasing the percentage of nitrogen and increasing the percentage of hydrogen? Because the solubility of helium is less, is very low in blood, and the solubility of nitrogen is very high. So if the solubility of nitrogen is very high in the blood, that means that our blood is our blood can there is a condition which is known as the bend condition. This is a very painful condition, that if the nitrogen dissolved in our blood is very high, then this condition will going to be happens, this disease will going to be happen. This is a very 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 painful condition, like your body is going to be squeezed out like this, and this will a very painful condition. So in order to avoid this condition, we just change the concentration. We decreases the percentage of nitrogen gas in the cylinder and increases the helium gas, because helium gas have a very low solubility in the water. So if I increase the helium gas and the pressure exerted more on the helium, it will not going to be dissolved more in the water, in the blood, because it is having a low solubility. Fine. In comparison to nitrogen. So this is the thing that
Fine.
we do in order to avoid this condition. These scuba divers that they'll do. Fine. So this is the one thing that you can see in the nature. Understood? Now there is another thing, which is
Yes.
if the hill climber will climbs up to the mountain. Like if they climbs up to the mountain, the there is another condition which is known as anoxia. And this in this condition,
Okay.
the oxygen to the brain is not going to be reached out at the optimum level that is required. Because if you are thinking, if you are learning, if you are doing something, and if you do any life process activity, there is an oxygen which is very 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 important to you in order to get the ATP, in order to get the energy. If you want the energy, if you want to perform the life processes, there is a thing which is known as the oxygen, which is required in an optimum amount that will going to be reached out to your brain. If the oxygen at the optimum amount is not going to be reached to your brain, there is some condition, there is some many diseases, like there is vomiting, there is बेहोशी की हालत हो जाती है. बेहोशी समझते हो? बेहोश बेहोश होता है इंसान. सो बेहोशी की हालत होने लग जाती है. एंड फीवर, है ना, you have a very high fever, you face vomiting, you have a very high headache. So these type of conditions you will face if you climbs up to very higher altitude. Why? Because at the higher altitude, the pressure is low. Because if you go deep down to the water, the pressure is high. If you go up at the higher altitude, the pressure is less. And if the pressure is less, that means that the concentration of the oxygen is less. If the concentration of oxygen is less, that means that the solubility in the blood of the solubility of oxygen in the blood is going to be decreased out. If the blood is in if the blood having a less supply of oxygen, that means the blood that will reach out to your brain have a low oxygen level, and this is responsible for these conditions. Are you understanding my point?
Yes.
Okay. Now the last application would be your CO2 gas, which is there in your soft drinks. If you open the bottle of the cold drink, the CO2 gas will be released out. So which is packed in a very higher pressure. Okay. So these are the applications which is there in the Henry's law. You need to learn these applications. If the examiner asks you to write the applications based on the Henry's law, you need to write all these three applications in your word, and I have explained the concept. Understood?
Yeah.
Can I move forward?
Yes.
Okay, fine. So just give me 1 second. Okay, so let's move forward to the next part. Fine. So we have discussed everything. If you face any difficulty, you can ask me any question related to these concepts, or
No, sir.
I can give you another question to you.
No, sir, I understood.
Clear everything?
Yeah.
Okay. So now, before giving you another question, there is another topic which is known as your vapor pressure. There is another thing which is known as your vapor pressure. Okay, vapor pressure. What is this vapor pressure? Can you tell me if you know anything?
Uh,
Hmm?
no, sir. Pressure applied by the vapor,
Pressure applied
by the vapor,
by the
vapors.
what?
Pressure applied by the vapors
Pressure applied by the
or
vapor.
the.
Correct. So basically, it is vapor applied by the sorry, it is the pressure which is applied by the vapors. But there is a special condition.
Mm.
What is this special condition? I'll tell you. I'm writing the complete definition of it, then I'll explain you. Okay. So the vapor pressure is the pressure. You can write with me, okay? Exerted by the vapors, exerted by the vapors of liquid when it is present in equi, equilibrium condition. Equilibrium condition. Okay, so with the liquid form. So this is the definition. So basically, if you see, the special condition is my equilibrium condition. What do you mean by this equilibrium condition? See, if I'm having a container, this is my container, fine, and this container having a liquid. This is liquid of A. Let's say A is something A is something compound, है ना? I'm just generalizing everything. A is something. So if I'm having a liquid of A, okay. So what will happen? This is there in the liquid form, but you know the evaporation thing. The vapor, the particles which is there on the surface of A is going to be evaporated and going to be there in the environment like this. These are the particles of A in gaseous form. Fine. So basically, there is
Yeah.
a this is a process of this is a process in which my liquid form is going to be converted into the vapor form, and this vapor form is again going to be converted into the liquid form. So this is a complete process of my what? This is a physical equilibrium. This is what? This is my physical equilibrium. What is physical equilibrium? The physical equilibrium is nothing but It is the equilibrium which is achieved. Equilibrium which is achieved, which is achieved. Equilibrium which is achieved between two different phases of particle, phases of matter, phases of matter. So phases of matter means that one will be in a gaseous phase and this one will be in liquid phase. So these are the two different phases of matter, and the the compound would be the same. The particles which is there in the vapor phase is A and the particles which is there in the liquid phase is A. So basically the two phases that are there in the container. So basically this is the equilibrium condition that is achieved. If the equilibrium condition is achieved, how? When the vapors which is forming, the rate of formation of vapors, the again listen my words carefully, the rate of formation of my vapors is equals to the rate of formation of my liquid. The rate of formation of my vapors, like in this journey, rate of formation of my vapor when equals to the rate of formation of my liquid, like from the liquid to the vapor, from the vapor to the liquid. This one would be my condensation, this one would be my evaporation. The rate of formation of my vapor means vaporization, and condensation again converting into the liquid form. If both the rates are going to be equalized, then this condition is my equilibrium condition, and that condition at which the equilibrium is achieved, the pressure which is exerted by the particles which is there in the gaseous form are known as my vapor pressure. That means that the vapors which is there exerts the pressure on the surface of the liquid is my vapor pressure when the condition is achieved, which is the equilibrium condition. And this equilibrium condition is nothing but when the vaporization is equals to the condensation. This equilibrium is my physical equilibrium, and at that condition the vapor which is the pressure which is exerted is known as your vapor pressure. Understood or not?
Yes.
Got it?
Equilibrium. Yeah.
If you face any difficulty, then ask me anything.
The equilibrium, physical equilibrium, could you
So what is
explain again?
equilibrium? You need to know what is equilibrium. Yeah, is it?
No, no, physical equilibrium. Yeah. Yeah.
Physical equilibrium. What is physical equilibrium? Yeah. So basically, physical equilibrium is nothing but
Yeah.
it is an equilibrium. Physical equilibrium is an equilibrium. It is a type of equilibrium in which the equilibrium is achieved when two phases of matter are there. Between where? Like for example, one is my vapor
Okay.
and the other one is my liquid. So if my rate of
Okay.
vaporization, what is vaporization? From the liquid form to the vapor form, and from the vapor form to the liquid form is my condensation. The rate of vaporization is equals to the rate of condensation. This equilibrium is known as my physical equilibrium. Why it is physical equilibrium? Because two different phases. The equilibrium is achieved between two different phases of the matter. The one would be is the gaseous form and the other one would be in the liquid form. So this is my physical equilibrium. Understood?
Yeah.
Got it?
Yes.
Yes. So this is my physical equilibrium. Correct. So this is my vapor pressure. Now this is all about for this for the today's class. Now in the next class we will discuss the factors which will affect your vapor pressure and more the upcoming next part. So I'm going to now I'll tell you what are the next upcoming parts. So the next upcoming part would be the first one would be the factors, and the next one would be my questions based on this vapor pressure, some questions. And the next one would be my colligative property. And this one would be my last topic. And in the colligative property, there are certain properties which are there. For example, elevation in boiling point, relative lowering in vapor pressure, relative, depression in freezing point, osmotic pressure. So these are some properties of the liquid, which is properties of the, basically, I can say the solution, which is there. So we'll discuss that, and then after there is another last topic, which is a very small last topic, which is my Van't factor. Then my chapter will be completed out. Fine. So this is all about
Mm.
of today's class, like vapor pressure. We have done what we have done. I'll again tell you, a short recap. So we have started from the solubility here. No, we have started from the homework question. The homework question is mine to find the molality, to find the mole fraction of the question which I have given you in the last class. So basically, this question is based on my concentration term. What we have done, we just apply the formula of my molality and applied the formula of my mole fraction. After applying these two formulas, I'll end up getting my answer just by putting the values. Fine. Now we have discussed the solubility. So basically, it is just nothing but the maximum amount of solid which is dissolved in the solvent. And factors affecting solubility is my first one is my temperature. Basically, temperature, how it will depend on the temperature. It is based on the process, which process we are talking about. Like for example, if we are talking about the endothermic process in which the energy is
Exactly.
required to you, that means the energy is basically required to you, means the energy is provided to you. So in that process, the solubility is basically, the temperature is basically directly proportional to the solubility. And if we talk about the exothermic process, this is the vice versa, because the exothermic process is the process in which the energy is released out. If the energy is released out, that means
Released.
that
Yeah.
we do not need to apply the external pressure. Just this is my if we apply the external energy, then the solubility is going to be decreased out. So basically, this is the two processes that the how the solubility depends on the temperature. Now the next one would be my pressure. So both of the liquid and the solids are incompressible. We can't compress them. That's why we are not going to discuss about the solubility based on the liquid and the solid. Now, but the thing which can be compressible is my gases. So we can compress the gas by increasing the pressure. If we increase the pressure, the solubility increases. है Now, the next one would be my nature of solute and solvent. So, if my both the natures of my solute and solvent are like for example, both of them are polar or both of them are non-polar, that means that the solubility increases.
Polar.
And we can say that if either one is my polar and the other one is my non-polar, then the solubility is going to be decreased out. And what is my pole? What is my dipole? Basically, what is my polar? So basically, polar is the compound having the dipole moment. What is dipole? Dipole is nothing but the two poles. The two poles. How the two poles? Basically, the two opposite equal charges are there, and which is separated by some distance. So this is my dipole. And the moment. What is moment? Dipole moment. The dipole moment is nothing but the multiplication of my magnitude of the charge to the distance. Magnitude of the charge to the distance. The multiplication of my magnitude of the charge to the distance is my dipole moment. And the dipole moment is there in the particles having a difference in the electronegativity. And I have explained you the electronegativity in the last class. What is electronegative, what is electropositive. Like electronegative are the elements which having a tendency to attack the shared pair of electron. So basically, if the tendency is having the shared pair of attracting the shared pair of electron is more, that means that it will have a partial negative charge, and this will have a partial positive charge automatically, because
Positive.
if the tendency is more, then it means that the opposite element which is connected to it having the less tendency. So this one will be my dipole moment. So this is my polar particle, and the see like the non-polar is this one. This is the non-polar. Why? Because this is my electropositive, this is my electronegative. So the dipole moment is like this. And if you see here, this is the dipole moment is like this. So this dipole moment is going to be cancelled out with this. And dipole moment is going to be applied here, and dipole moment is here. So both the dipole moment is going to be cancel out each other. And if both the dipole moment will cancel out each other, that means that this is the non-polar. This is my non-polar compound. Fine. So non-polar likes
Yeah.
non-polar, polar likes polar. If we combine both of them, the solubility is automatically decreases. Now the next one would be my Henry's law. Very important. So the partial pressure is directly proportional to the pressure that we have applied. Partial pressure is directly proportional that we applied the partial pressure is directly proportional to the mole fraction basically. And how the mole fraction is there in my liquid solution. Fine. And this is my formula, this is my thing, and this is my Henry's constant. This is my graph. Now the application is bend condition. The scuba diver go down to the deep of the ocean. The pressure increases. The pressure increases. If the pressure increases, then we need to change the concentration of the oxygen cylinder that they carry with them, because in the air the nitrogen is there in a higher quantity. But if we go deep down to the water, we have need less nitrogen, because nitrogen will occur a condition which is known as a bend condition. It is a very painful condition. The next one would be my climbing to the higher altitude. If we climb to the higher altitude, the oxygen is less. Oxygen quantity is less. If the quantity of the oxygen is less, that means that the pressure is less on the oxygen. So if the pressure is less, that means that the the blood having a less quantity of oxygen that will dissolve in it. If you breathe in, the less number of oxygen will comes up into the body, and the dissolution with the blood of oxygen will be less, and that blood will comes up to the brain is having a less oxygen. If the blood having the less oxygen, that will comes up to the brain, causes some severe conditions like the vomiting, fever, headache, etc., and etc., and these conditions are comes under the anoxia. And the last one would be my CO2 bottle, CO2 holding bottle. If you open that bottle, the CO2 will escape out, and how this CO2 will be packed in it just by the Henry's law. That's it. Now, this is the question that we have discussed. Everything we have discussed, Anna.
Yeah.
And the last one would be my vapor pressure. Vapor pressure is nothing but the pressure which is exerted by the pressure, but the condition is that this should be in the equilibrium. That's it. Fine. So this is all about the today's class. Everything that I have taught to you, I have quickly revised all the topics. Understood?
Nice.
Fine. Okay. So now
Fine.
we discuss more from here in the next class. Okay. Okay, you may leave now.
Okay.
If you do,
Fine.
if you have